You see, Darwin's ideas about the development of life led to his theory that modern science now generally defines as an undirected process, completely devoid of any purpose or plan. Now, how could God direct an undirected process? How could God have purpose and a plan behind a system that has no plan and no purpose? It just does not make sense. And so I decided to use my legal training and journalism training, my scientific curiosity, to systematically investigate, is there any credibility to the Christian faith?
Because science had played such an instrumental role in his turn to atheism, Strobel embarked on an investigation of major discoveries in biology, chemistry, cosmology, and physics. His studies spanned more than 20 years and included interviews with scientists and scholars as he sought to determine for himself what these discoveries implied about the reality of a creator. Throughout his inquiry, one question remained constant. Does the evidence uncovered by contemporary science point us toward or away from the existence of God?
Two-time Nobel Prize winner Linus Pauling once said that science should be the search for truth. And that's what I wanted to do. I didn't know where the evidence was ultimately going to take me, but I really did want to know the truth about God. And what I found shocked me and it stunned me.
Strobel's search began with an examination of evidence that challenged materialistic theories of life's origin. He discovered that this negative evidence contradicted the textbook explanations that had once convinced him the blind forces of evolution could account for the creation and diversity of life on Earth.
A good example of negative evidence is the 19...
Okay, before Lee Strobel starts attacking abiogenesis and the Urey-Miller experiment, I'd like to quickly go through some of the history. I'm not going to get into the science. It's amazing to learn about it, but I'm not going to. First, we have the Urey-Miller experiment that really started off the research for abiogenesis. He showed that biomolecules can form in a reactive environment of, water, hydrogen, and it's hydrogen, methane, and ammonia. Which he was correct in that, even though the early Earth was shown to have a different, that's very good, since we didn't really think many biomolecules would form on their own like that. Next we have John Orell's Leslie Orgel, who used concentrations of chemicals by purifying them and concentrating them down through various methods, and getting various amino acids that were missing from the Stanley Miller experiment. Then, even though they're Lee Strobel's gonna go after the environment, we don't have that. If you look deep, if you look anywhere, I mean anywhere on the planet, we find life. Okay, deep in the rocks, in oil, deep in the ocean, volcanoes, even nuclear waste. It's everywhere. So don't think that life is just is as fragile as they're trying to make it sound. Even in outer space, we find biomolecules, and experiments have been shown. Robert M. Hazen's has shown that extreme pressure. There's one girl who used, I forget her name, but she used a gas gun, which basically just shot out huge things of rock with amino acids and stuff, and showed that even though meteorites could have hit the Earth, that could have delivered some essential amino acids or some biomolecules or something. That's not saying transpermia, but some of the biomolecules from space could have happened. Could have come down like that. It's likely. I mean, it's not likely, but it could have happened. That's pretty much all I care to say. That's just about the history, not the science, but yeah. Till next time.
As biologist Jonathan Wells explained to me, Miller's experiment has now been thoroughly discredited.
Stanley Miller put together a glass apparatus, and in that apparatus he put a mixture of gases that people at the time thought reflected the atmosphere of the early Earth. And those gases were methane, ammonia, hydrogen, and water vapor. But then the professional opinion of what was there on the early Earth changed. In the 60s, geochemists revised their hypothesis and decided that the hydrogen, being very light, would have escaped into outer space. The Earth's gravity isn't strong enough to hold it. And probably the early Earth's atmosphere then consisted of what we now see coming out of volcanoes today, namely carbon dioxide, nitrogen, and water vapor. Well, if the early Earth's atmosphere consisted of those gases, then Stanley Miller's experiment would not work. In fact, he himself tried it with those gases, and he found that he couldn't produce any amino acids at all. So the experiment falls apart once you use a more realistic mixture of gases in the apparatus.
Miller's test has been repeated many times using the correct atmospheric components. The results are always the same.